This video will be a review for the quiz. The quiz will have 13 problems. Problems 1 and 2 will involve verifying identities. You can consult the previously made videos, there were 3 of them, on verifying identities. You can also use your homework for examples or the examples from the text. Problem number 3 is going to come from lesson 5.2. So you can also consult that video. And there are examples of how to do this on there. We want to find the exact value of, and you may have to do a cosine or you may have to do a sine. So I'll give an example of each of those. The cosine of 210 degrees. So we had a formula from lesson 5.2 that the cosine of alpha plus beta is equal to cosine alpha, cosine beta minus sine alpha, sine beta. So what we have to do is rewrite 210 degrees as the sum of two angles that we can find the cosine of without using our calculator. So I used 180 degrees and 30 degrees. So I plug in alpha is 180 and beta is 30. Then to find the cosine of 180, I'm going to use the unit circle. After a turn of 180 degrees, you land here. The cosine is -1, it's the x coordinate. The sine is 0. So that's where I'm getting this and this. Then for the 30 degrees, I use my 30, 60, 90 triangle. Cosine is adjacent over hypotenuse. So the cosine of 30 degrees is radical 3 over 2. The sine of 30 we really don't need to do because 0 times anything is 0, but I did it anyway. The cosine of 30 is opposite over hypotenuse, so it's 1/2. Putting those together, you get negative radical 3 over 2. Here's an example of finding the exact value of the sine of 105 degrees. So the sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha times sine beta. I break up 105 degrees into two angles that I know, so I use 60 and 45. I plug in alpha is 60, beta is 45. Using my special right triangles, the sine of 60 degrees would be the opposite over the hypotenuse, so radical 3 over 2. The cosine of 45 degrees would be 1 over radical 2, but you should always rationalize your denominator. So multiply top and bottom by radical 2 over radical 2, which is how I get radical 2 over 2. The cosine of 60 degrees is 1/2, using the adjacent over the hypotenuse. The sine of 45 degrees is also radical 2 over 2. Put these together, it's radical 6 over 4. Radical 2 over 4 all together is radical 6 plus radical 2 all over 4. Problem number 4 on the quiz is going to come from lesson 5.3. This is going to use one of the double angle formulas. Write as a sine, cosine, or tangent of a double angle, then find the exact value. So I'm given cosine squared 105 degrees minus sine squared 105 degrees. Going back to our double angle formulas that were in our notes, that looks a lot like this right here. Cosine squared of an angle minus sine squared of an angle is equivalent to the cosine of twice that angle. So I want to take this and rewrite it as the cosine of twice 105 degrees. That's equal to the cosine of 210. Now, we already did this in the last example, so you could do it this way, but that's a little more time consuming. We can also look at the fact that we have a circle and a 210 degree turn would land us in quadrant 3, which means that the cosine would be negative. The reference angle right here would be 30 degrees because 210 degrees, take away 180 degrees, what's left is my reference angle 30 degrees. So I'm looking essentially for the cosine of 30 degrees. Going back to my special triangle here, the cosine is adjacent over hypotenuse. So it's negative radical 3 over 2. Problem number 5 on the test will come from lesson 5.5. Solve on the interval 0 to 2 pi. 2 cosine squared x is equal to 4 cosine x plus 6. What you want to do is get everything over to one side of the equation. So subtract the 6 and subtract the 4 cosine x. So I get 2 cosine squared x minus 4 cosine x minus 6 equals 0. Then, because it's quadratic, that means I have a squared right here, I want to factor it. So this is where you put it into the form before you did the FOIL method. And so that is going to look like this. The first term, I need to do 2 times 1 of cosine of x. I've got a negative 6 here. I need to think of factors of negative 6. One's going to have to be positive. One's going to have to be negative. And you just do the FOIL method and you do trial and error until you get it where the outer terms and the inner terms give you negative 4 times the cosine of x. So this is negative 6 cosine x plus 2 cosine x, and that's how I'm getting this. Next, set each of the factors equal to 0 and solve. So first, 2 cosine x plus 2 equals 0. Subtract the 2, divide by 2. The cosine of x is negative 1. To figure out where the cosine of x is negative 1, think of the unit circle. The cosine of x is negative 1 here, because cosine is the x coordinate. That was a turn of 180 degrees or pi radians. We want to make sure we put it in radians because our interval was given in radians. For the second one, I set the cosine of x minus 3 equal to 0. I add the 3 to both sides, and there's no solution here because the cosine of x can never equal 3. It has to range from negative 1 to 1. So we only have one solution, and that is pi. For problem number 6, it's going to be another problem from lesson 5.5. Specifically, look at example 2. So if you need to rewatch video 5.5, example 2 will be very similar to the quiz problem for number 6. Problem number 7, you're going to want to solve the triangle where A is 70 degrees, lowercase a is 39, and B is 35. So this comes from lesson 6.1, the law of sines. So first, draw a picture. The law of sines, you're going to set up a proportion. The sine of B over 35 is equal to the sine of 70 over 39. Cross multiply and then solve. Make sure your calculator is in mode degrees. Once you get to this step, you're going to do inverse sine, which is second sine on your calculator. And if you're in mode degrees, it will give you approximately 57.5 degrees. To find angle C, we know that there are 180 degrees in any triangle, so just subtract A and B, and that will give you the measure of angle C. There's only one more thing left to find, and that is side C. So we can use the law of sines again. And notice that when I set up the law of sines, I did it slightly differently than the way it was in the notes. in the notes, I had the side over the sine of the angle equals the side over the sine of the angle. What I did here, it doesn't really matter. I flipped and took the reciprocal of both of the sides. So it's equivalent to take the sine of the angle over the side equals the sine of the angle over the side. It really doesn't matter, because once you cross multiply, it's going to be the same thing. So the fraction, as long as the sign is in the same location, they can either both be in the numerator or both in the denominator. Cross multiply, making sure you're in mode degrees, divide by the sine of 70 degrees, and you get that C is approximately 32.9 units. For problem number 8 on the quiz, you're going to want to refer to the video from lesson 6.2, specifically look at example 2. In lesson 6.2, you were doing the law of cosines. So you can go back to the video and it's going to show you how to do the law of cosines for a problem like this where you are given all 3 sides.